The morning sun cast long shadows across the military airfield as Major Sarah Collins stood before the massive Chinook helicopter, her face etched with frustration. For 3 weeks, the twin-engine aircraft had been grounded, its port engine refusing to cooperate despite the best efforts of the base's engineering team. What should have been a routine maintenance check had turned into a nightmare that threatened to compromise critical supply missions to remote outposts. The engine's problem seemed simple enough on the surface. During a routine flight test, the port turbine had begun producing irregular vibrations, followed by a series of warning lights that forced an emergency landing. The initial inspection revealed nothing obvious, but subsequent attempts to restart the engine resulted in the same disturbing symptoms. Temperature readings spiked unexpectedly, fuel flow patterns became erratic, and a metallic grinding sound emerged from deep within the turbine housing. Captain Mike Rodriguez, the lead engineer assigned to the case, had assembled his best team for what he assumed would be a straightforward repair. The maintenance manual was thick with diagnostic procedures, and they followed each step methodically. They replaced the fuel injectors, cleaned the combustion chambers, and even swapped out the entire ignition system. Yet every test run ended the same way, with alarms blaring and the engine shutting itself down as safety protocols kicked in. The pressure was mounting from headquarters. The Chinook was desperately needed for a series of humanitarian missions in mountainous terrain where only the heavy-lift helicopter could safely operate. Soldiers and civilians alike were counting on supplies that only this aircraft could deliver to locations unreachable by ground vehicles. Each day of delay meant putting lives at risk and compromising operational readiness. Rodriguez found himself working 18-hour days, poring over technical manuals and consulting with engineers from the manufacturer. Video calls with technical support specialists in different time zones became routine, but their suggestions only led to more dead ends. The team had dismantled and reassembled major engine components multiple times, each iteration consuming precious time and resources without bringing them closer to a solution. The young engineers on Rodriguez's team were equally frustrated. They had trained extensively on modern diagnostic equipment and computer-aided troubleshooting systems. But this problem seemed to exist in a gray area between electrical, mechanical, and thermal systems. Every computer scan came back clean, yet the engine's behavior clearly indicated a serious malfunction somewhere in its complex machinery. Dr. Amanda Chen, a civilian contractor specializing in turbine engineering, joined the effort in the second week. Her reputation for solving impossible mechanical puzzles had preceded her arrival, and the team welcomed her expertise with relief. She brought cutting-edge diagnostic equipment that could peer into the engine's operation with unprecedented detail, measuring variables that the standard military equipment couldn't detect. For days, Chen ran test after test, her instruments capturing thousands of data points during each attempted startup sequence. The readings painted a confusing picture of an engine that should work perfectly, but consistently failed at the same point in its startup cycle. She cross-referenced the data with similar engines in service worldwide, looking for patterns that might explain the mysterious malfunction. The breakthrough seemed to come when Chen discovered slight irregularities in the fuel mixture ratio during the critical transition from startup to operational speed. The variations were tiny, barely within the margin of error for the measuring equipment, but they occurred with suspicious consistency. She theorized that a microscopic obstruction in the fuel system might be causing these fluctuations, leading to the cascade of failures they were witnessing. Acting on this theory, the team performed the most thorough fuel system cleaning in the helicopter's service history. They flushed every line, replaced every filter, and used ultrasonic cleaning equipment to remove even the tiniest particles from the fuel injectors. The process took 3 days of meticulous work, with each component inspected under magnification before being reinstalled. The first test after the fuel system overhaul seemed promising. The engine started normally, with all temperatures and pressures reading within acceptable ranges. For 20 minutes, it ran smoothly while the team held their breath and monitored every gauge. Then, just as they began to celebrate, the familiar warning lights appeared and the engine began its troubling vibration pattern once again. Rodriguez felt the weight of failure settling on his shoulders as he watched the engine shut itself down for what felt like the 100th time. His team's morale was visibly dropping, and he could see doubt creeping into their faces. They had tried everything in their considerable toolkit, consulted every available expert, and followed every logical troubleshooting path. The helicopter remained as grounded as ever, and time was running out. The situation became even more urgent when General Patricia Hawkins arrived for an unscheduled inspection. Known throughout the military for her no-nonsense approach to problem-solving, she listened to Rodriguez's detailed briefing with growing impatience. The general understood the technical complexity of modern aircraft, but she also understood that soldiers in the field were depending on this helicopter for their survival. Standing in the shadow of the grounded Chinook, General Hawkins faced a decision that would either solve the crisis or add another layer of complexity to an already impossible situation. The conventional approaches had failed, the best technical minds had reached their limits, and time was running out. It was then that she remembered a conversation from months earlier, a casual mention of an old mechanic who had worked on these engines decades before modern computerized systems existed. The suggestion had seemed quaint at the time, but desperate circumstances called for unconventional solutions. Frank Morrison was tending to his vegetable garden when the black sedan pulled into his driveway, its government plates catching the afternoon sunlight. At 73, the retired Army sergeant had grown accustomed to quiet mornings and peaceful evenings, far removed from the chaos of military life he had left behind 15 years earlier. The unexpected visitors disrupted his routine of watering tomatoes and checking on his prized bell peppers. General Hawkins stepped out of the vehicle with a purposeful stride, her uniform crisp despite the long drive to Morrison's rural home. She had spent considerable effort tracking down the old mechanic, following leads through personnel records and retirement databases. Most people who remembered Morrison spoke of him with a mixture of respect and amazement, describing someone who could diagnose engine problems by sound alone and fix machinery that others had given up on. The general found Morrison exactly as described, a weathered man with calloused hands and sharp eyes that seemed to take in every detail of his surroundings. His small workshop behind the house was immaculately organized, with tools arranged according to some personal system that spoke of decades of precision work. Handwritten maintenance logs dating back 40 years filled several filing cabinets, evidence of a methodical approach to mechanical problem-solving. Morrison listened quietly as General Hawkins explained the helicopter crisis, his expression remaining neutral as she described the failed attempts by modern engineers and sophisticated diagnostic equipment. He asked few questions, but those he posed revealed an intimate understanding of turbine engine operation that impressed even the general. When she finished her briefing, Morrison sat in contemplative silence, his gaze fixed on some distant memory. The drive back to the airbase gave Morrison time to reflect on engines he had worked on decades earlier, before computers and sensors transformed aircraft maintenance. He remembered the CH-47 Chinook from its early service years, when mechanics relied on experience and intuition rather than diagnostic software. Those engines had their own personalities, quirks that experienced hands could feel through vibrations in the airframe or subtle changes in the sound of rotating machinery. Morrison's first glimpse of the grounded helicopter brought back memories of countless repair challenges from his military career. He approached the aircraft with the slow, deliberate movements of someone who understood that rushing led to mistakes. While Rodriguez and his team watched with skeptical curiosity, Morrison began what appeared to be a casual inspection of the troublesome engine, his hands moving over components with familiar confidence. The modern diagnostic equipment impressed Morrison, but he also noticed how dependent the younger engineers had become on their computer readouts and digital displays. They could recite technical specifications from memory and interpret complex data streams, but they seemed disconnected from the physical reality of the machine they were trying to repair. Their approach was systematic and thorough, but it lacked the intuitive element that came from decades of hands-on experience. Morrison requested permission to listen to the engine during a startup attempt, positioning himself near the air intake while Rodriguez initiated the test sequence. As the turbine began its startup cycle, Morrison closed his eyes and concentrated on the symphony of mechanical sounds emanating from the engine housing. To the younger engineers, the noise seemed like random mechanical chaos, but Morrison heard distinct patterns and subtle variations that told a story of internal component interaction. When the engine reached the point where it typically began showing symptoms, Morrison raised his hand to signal Rodriguez to shut down the test. He had heard something in those few seconds that none of the sophisticated monitoring equipment had detected: a barely perceptible irregularity in the harmonic frequency of the rotating components. The sound lasted only a fraction of a second, but it provided Morrison with a crucial clue about the nature of the malfunction. Morrison spent the next hour examining components that the engineering team had already inspected multiple times. His approach seemed random to the observers, but he was following a logical progression based on his interpretation of the acoustic evidence. He paid particular attention to areas where different systems interfaced, understanding that problems often occurred at connection points rather than within individual components. The breakthrough came when Morrison discovered a tiny crack in a mounting bracket that connected the engine to the airframe. The crack was so small that it had escaped detection during previous inspections, hidden beneath layers of paint and requiring careful examination under specific lighting conditions to reveal itself. The fracture was allowing microscopic movements during engine operation, creating vibrations that confused the computer control systems. Dr. Chen was amazed when Morrison pointed out the damaged bracket. Her sophisticated instruments had measured thousands of variables, but had missed this simple mechanical failure because it fell outside the parameters of their programmed search algorithms. The crack was causing the engine mounting to flex slightly under load, which in turn affected fuel flow patterns and created the mysterious symptoms that had puzzled the engineering team for weeks. Rodriguez examined the cracked bracket under magnification, confirming Morrison's diagnosis and feeling a mixture of admiration and embarrassment. The repair would be relatively simple, requiring only the replacement of a small mounting component that cost less than $50. The part was readily available in the base supply system, and the installation could be completed in a few hours by any competent mechanic. As the sun set over the airfield, Morrison watched the younger engineers prepare for the bracket replacement, their earlier skepticism replaced by genuine respect for his diagnostic abilities. He offered to supervise the repair work, sharing insights about proper torque specifications and installation techniques that weren't covered in the modern technical manuals. The old sergeant understood that fixing the immediate problem was important, but teaching the next generation of mechanics was equally valuable. The repair proceeded smoothly under Morrison's guidance, with each step executed according to standards that had proven reliable over decades of military service. He emphasized the importance of understanding how individual components affected overall system performance, encouraging the team to think beyond their specialized areas of expertise. The lesson was clear. Modern technology was powerful, but it couldn't replace fundamental mechanical understanding and hands-on experience. The morning air was crisp and clear as Rodriguez initiated the first engine test following the bracket replacement. Morrison stood nearby, his experienced ear tuned to every nuance of the startup sequence, while the engineering team monitored their instruments with nervous anticipation. General Hawkins had arrived early to witness what everyone hoped would be the end of the 3-week nightmare that had grounded one of their most critical aircraft. The engine spun up smoothly, its turbine blades cutting through the air with the steady rhythm that Morrison remembered from decades of successful operations. The temperature readings climbed steadily within normal parameters, fuel flow remained consistent, and most importantly, the mysterious vibrations that had plagued previous attempts were completely absent. For the first time in weeks, the helicopter's systems reported normal operation across all monitored parameters. Morrison nodded approvingly as the engine reached operational speed without triggering a single warning light. The repair had addressed not only the immediate problem, but also several minor issues that had been masked by the primary malfunction. The new mounting bracket provided the solid foundation that the engine control systems needed to function properly, eliminating the microscopic movements that had confused the sophisticated sensors and algorithms. Dr. Chen reviewed the diagnostic data with amazement, noting how all the previously puzzling readings now made perfect sense when viewed in the context of the mounting bracket failure. The tiny movements had created a cascade of secondary effects that manifested as fuel system irregularities, temperature fluctuations, and harmonic vibrations. Her instruments had faithfully recorded these symptoms, but without understanding the root cause, the data had been meaningless. The successful engine test was followed by a comprehensive systems check that validated all helicopter functions. The crew chief ran through every operational procedure, confirming that the aircraft was ready to return to active duty. Flight controls responded normally, hydraulic systems maintained proper pressure, and the electrical systems showed no signs of the interference patterns that had appeared during the malfunction period. Rodriguez felt a profound sense of relief as he signed off on the maintenance records, officially returning the helicopter to flight status. The experience had been humbling for the young engineer, demonstrating that modern technology, while powerful and sophisticated, could not replace the deep understanding that came from years of hands-on experience. Morrison had solved in hours what computers and advanced diagnostics had failed to identify over several weeks. General Hawkins wasted no time in scheduling the helicopter for its first mission since the grounding. The aircraft would carry medical supplies to a remote mountain outpost where injured soldiers were awaiting evacuation. The mission held special significance for everyone involved, representing not just a successful repair, but a return to the life-saving operations that justified their efforts and expertise. As the helicopter lifted off for its mission, Morrison watched from the flight line with quiet satisfaction. The sound of the engines was exactly as it should be, strong and steady without the subtle irregularities that had characterized the malfunction. He could hear in those rotating blades the voices of countless mechanics who had maintained aircraft before him, their knowledge and experience living on in the hands of the next generation. The mission proceeded flawlessly, with the helicopter performing all required maneuvers without any hint of the problems that had kept it grounded. The pilots reported excellent engine response and normal operational parameters throughout the flight. The medical evacuation was completed successfully, bringing injured soldiers to the care they desperately needed and demonstrating the critical importance of maintaining these complex machines in perfect working order. In the days that followed, Morrison's diagnostic success became the subject of considerable discussion throughout the engineering community. His ability to identify a problem that had stumped modern equipment sparked conversations about the balance between technological advancement and fundamental mechanical understanding. Many younger mechanics began seeking opportunities to work alongside experienced veterans, recognizing the value of knowledge that couldn't be programmed into computers. Rodriguez implemented changes to his team's diagnostic procedures, incorporating acoustic analysis and physical inspection techniques that Morrison had demonstrated. The new protocols emphasized the importance of using multiple approaches to problem solving, combining modern instrumentation with traditional mechanical knowledge. These changes proved valuable in subsequent maintenance challenges, leading to faster and more accurate diagnoses. Morrison agreed to conduct training sessions for the engineering team, sharing insights accumulated over 4 decades of military aircraft maintenance. His informal classroom sessions became popular among mechanics from across the base, as word spread about the old sergeant who could diagnose problems that computers missed. The training covered everything from interpreting engine sounds to recognizing visual indicators of component stress. The helicopter continued to perform flawlessly in the months following Morrison's repair, completing dozens of critical missions without any recurrence of the original problem. The new mounting bracket proved more durable than the original component, and subsequent inspections confirmed that the repair had addressed the root cause of the malfunction. The aircraft returned to its role as a reliable workhorse, carrying supplies and personnel to locations where ground transportation was impossible. Dr. Chen incorporated Morrison's diagnostic approach into her own methodology, developing new instruments that could detect the type of mechanical irregularities that had escaped her original equipment. Her research led to improved diagnostic protocols that combined acoustic analysis with traditional sensor data, creating a more comprehensive approach to engine troubleshooting. The work earned recognition from the engineering community and influenced maintenance procedures across multiple military services. General Hawkins used the helicopter incident as a case study in military leadership courses, demonstrating the importance of seeking unconventional solutions when traditional approaches fail. Morrison's success illustrated how institutional knowledge, preserved in the experience of retired personnel, could provide solutions that modern technology alone could not achieve. The lesson emphasized the value of maintaining connections with experienced veterans who possessed irreplaceable hands-on knowledge. The story of Morrison's diagnostic triumph spread beyond the immediate military community, becoming an example of how human expertise remained relevant in an increasingly automated world. Engineering schools began incorporating case studies that highlighted the importance of fundamental mechanical understanding alongside modern technological tools. The incident served as a reminder that sophisticated equipment enhanced human capability, but could not replace the insight that came from decades of practical experience. Years later, Rodriguez would credit Morrison with fundamentally changing his approach to engineering problems. The encounter taught him to listen more carefully to machinery, to trust his instincts when computer readings seemed inconsistent with observed behavior, and to seek input from experienced colleagues when facing unprecedented challenges. These lessons served him well throughout a distinguished career that eventually led to his own promotion to senior engineering positions. Morrison returned to his quiet retirement, but his workshop saw more visitors as young mechanics sought his guidance on challenging problems. He continued to share his knowledge freely, understanding that the techniques and insights he had developed over his career would die with him unless passed on to the next generation. His legacy lived on not just in the successfully repaired helicopter, but in the enhanced skills and broadened perspectives of the engineers he had taught.